My name's Nick. I started Nick's Electronics Repair 10 years ago, and since then we have fixed over 25,000 devices. In this video, I'm going to show you how we fixed this controller board for a Maytag oven, and the issue the customer was experiencing is that the oven would just not turn on or just not get to temperature. So let's get started. The main cause or reason for an oven not to get to temperature is typically going to be cracked solder joints. Those most commonly occur underneath these relays over here. So we're going to do a visual inspection underneath all of those. Unfortunately, we do have this plastic cover, which is hindering our ability to properly see the board. So let's remove it first. First, let's check out the relay right next to that transformer. And these are the 5 pins for the relay. Those look actually okay. I don't see any sort of burning or cracked solder joints. Let's make our way over to this relay over here. And for this one, the pins are going to be right over here and these two here. And this relay also looks okay. Let's check out our next one right below it. And here we are. We have a burn mark right here. This pin is definitely burnt. I can see a little burning. And the contact between the solder on the PCB and the leg of the relay is no good. So what we'll do next is remove this relay out of circuit, test it, make sure it's functional. If it is, we'll go ahead and put it back in. If it is defective, we'll go ahead and replace it. Now, 99% of the time, the relays are actually fully functional. It's very rare that they become defective. So I am guessing that this unit, this relay specifically, is going to be working, and we'll just reinstall it. So I believe the joints for my relay are obviously this burnt one over here, and I'm going to start by adding some solder to it. I believe this one is another one of my joints right here. And then these two little guys is where the power comes in, letting the relay to know that it needs to activate. Okay, now we'll go ahead and desolder. And we're just using desolder wick here, nothing fancy. Now, if you're interested in sending in your controller board for us to fix, we'll have links to our flat rate repair services in the video description down below. All right, and then for the last joint, I'm just gonna go ahead and melt it. And we're gonna pull the relay through. And here we are. All right, now let's clean off all of that remaining solder. And we're going to give it a quick little clean, remove some of the flux. Now, I didn't add flux to the board, but there is already flux in the solder that I used, as well as the desolder wick. With my multimeter in continuity mode, we get a beep when we have a short. Let's check our relay, and we have no short at this moment, which is correct. That's what we're expecting. Now let's connect our DC power supply to the input legs. Let's turn it on. So we just heard that click, and just so you know, we have 9 volts from the DC power supply. It is a 12-volt relay, but 9 volts is typically enough to trigger the relay to activate. So if you don't have a DC power supply, but like a 9-volt battery will be good enough to trigger that relay. So let's go ahead and do a check, and sure enough, we have a short. We get continuity. So that means the relay is properly activating, and I just heard it click off. Let's make sure that it is no longer shorted, and it is not. So that confirms this relay is good. We can go ahead and reinstall it. The issue was purely that cracked solder joint. All right, so we're just gonna feed our relay back in. All right, so now we'll go ahead and solder that down. And I'm hanging out on the joint for a little bit longer here just because I want to make sure that I have good heat transfer from the soldering iron both to the trace on the PCB as well as the leg of the relay. If the leg of the relay or the trace on the PCB is not getting hot enough, I'm not going to get a very good bond with the solder. So it's really important to have that good heat transfer. All right, we'll go ahead and do another little clean, get rid of some of that flux. Okay, and while technically this board is now repaired, this is not where we're gonna stop. The reason why is because these cracked solder joints do occur often with these boards. So what we're gonna do here is we're gonna go ahead and actually reflow and renew all of the solder joints on every single relay on this board. If the solder joints on this relay here just failed, then that means that the other relays are probably not too far behind. So we'll do a full reflow of this circuit board to ensure that this board does not have any problems in the near future. All right, so actually for the rest of the soldering that we're gonna do here, we're gonna switch over to our microscope. And if you notice here, this is the first relay we took a look at. And while I didn't notice any physical damage, I can see that it's starting to crack right over here where I'm putting the solder filament. So what that means is that this relay, this joint is not too far behind and could have damage to it very soon. So we're gonna go ahead and add some new solder and reform that bond. Okay, now we have a fresh solder bond that's gonna last for many years to come. And we're just gonna repeat that a few more times on the other relays. Again, making sure I have good heat transfer between the iron, the leg of the relay, and the trace on the PCB. All right, so that's all the relays on that side. Now these are smaller relays, so I probably don't need to spend as much time on the joints, but we still want to reform those bonds. So yeah, these relays with the 5 pins like this are less likely to get cracks, or at least that's what I've noticed over the years of fixing these, but we still want to go over those joints just to be sure. It is time consuming and a decent amount of effort to get to this board, remove it out of the oven. So might as well fix the board correctly with the long term in mind so that this does not have to be repeated every couple of years. So that does complete the reflow of all of our relays, but there's actually one more part that we also want to reflow that can get cracked solder joints, and that's the connector pins. So every single connector pin down here, over here, and the larger ones over here that have a lot of power going through them can and do tend to crack over time. So we're gonna also reflow those. Now, if we look at a few specific ones, this one I'm also starting to see a little bit of cracking occurring on the outer edges. These are somewhat okay. The second one is also a little bit heat stressed. This 3rd, 4th, 5th, 6th look okay. This one over here looks heat stressed, and so does this one over here. Actually, this one looks pretty bad. So we're definitely gonna want to touch that up. Whoop. And our final 2 joints. Perfect. Now we can go ahead and give the whole board a clean. And this does complete our repairs for this Maytag controller board. If you're interested in seeing more content on oven range controller board repairs, check out this video next. Otherwise, if you found the content helpful or useful, make sure to leave us a like, subscribe for more, and thank you for watching.